All right, so in this unit, we look at charges and electric fields, and the most basic fundamental of this unit is looking at what an electric charge is, which it's a property of subatomic particles, in this case, electrons and protons, electrons being negative, protons being positive. And the SI unit of charge is known as the coulomb, or also written just as C, which the lowest possible unit of that being, the lowest SI unit of that, whether it is positive or negative, is 1.602 times 10 to the negative 19 coulombs. And that's the unit for electric charges. The law of conservation of charge states that charges can't be created, but rather must be transferred from one object to another. So if we have an object with, say, 2 negatives and 2 positives, and then we have another one with the same thing, if you were to rub these two together, which is known as the triboelectric effect, if you were to physically rub these objects together, these electrons are going to transfer over to this other object, leaving this one to be net positive and this one to be net negative. Then we move on to the force of attraction, which is directly proportional to the amount of charge and also directly proportional to the proximity of the opposing charges. So if we have 2 positives and 2 negatives, that transfers to something else and now becomes maybe 3 negatives and 2 positives. That's going to be a lot weaker than if we have something else that has, I don't know, say 7 negatives and 3 positives, which is going to have a net charge of -4. And then also, if an object is going to be closer to this object, it's going to experience a greater force of attraction if it's the opposing charge. Then moving on to kind of a spiderweb analogy. I can't draw a spiderweb, but let's just say that that's a spiderweb. Nothing is going to happen with the spiderweb unless a little fly comes into contact with this web. And I have a little video actually recently of these magnets. Where essentially it looks like I'm playing around and messing around with it, but the magnets don't interact at all unless you bring them within a certain level of proximity together, which goes along with this spiderweb analogy, saying that nothing is going to happen unless it actually comes into contact within the electric field. Now, the strength of the electric field, as we said before, is going to lead to having either more charges or being within closer proximity of the electric field. That is both going to be proportionally more attractive between forces than if you were to have less charges or if you were to be further apart. Now, net force, just as a quick clarification, means if you have 7 positives and you have 7 negatives, you have a net force of 0. You are literally canceling out one of each every time you do that to get a net of 0. But if you start adding in a few more negatives, then when you cross them out, you're going to find that you have a net charge of -3. And again, same thing can happen if there were 3 extra positive charges rather than negative. Then there's conductors and insulators, just quick little mention of these. conductors work regardless of the conditions, and it indicates that electrons in the element's outermost shell are available to move freely between atoms, which they call these conductor electrons. They're ready to let these electrons move freely, whereas insulators, as you can probably guess, don't have a lot of conductor electrons. Now, charging by induction is if you took two neutral objects, if isolated, they can actually become charged without being touched by a charged object. So instead of the triboelectric effect where we're actually touching the two objects together, if two neutral spheres, oh, guess we're using purple, two neutral spheres were next to each other, and then a positively charged glass rod were to approach but not actually touch one of the spheres. Actually, these spheres are going to be touching. If you actually bring this charged rod close to the one edge of one of the spheres, that's going to cause a shift in the polarity. It's going to make the negatives shift to one side and the positives shift to the other side. And when you separate the two spheres, if you were to separate these two with the rod still in this location, you would end up with two spheres that still have that separation of charges. Terrible drawing, but you get the idea. So that's kind of a summary of this unit, and yeah, on to the next one.